Recently I got into 3D printing and I bought one of the Creality CR10S's and was quite happy with it. Um, but there was some safety issues with it. Some of that is dealt with in firmware, which I haven't upgraded, but I constantly get the warning from Octoprint that the firmware is unsafe. Um, So there's things on it that could inherently be made safer, obviously, but there's some external stuff that you can add to make it safer. One of them is shutdowns based on smoke detectors. Now, I've gone out and purchased a cheap, inexpensive smoke detector from a local hardware store. This one was about $10, and came with battery. Surprise, I don't know how they make money on this, $10. Um, there's really not much to these things. I mean, you have a radioactive source for ionizing the gas, and the piezoelectric buzzer, which they all have this. Um, So the idea is that we don't want to change the functionality of the smoke detector in any way, but we want to pick off a signal to trigger a circuit to shut down the printer when the smoke detector has been triggered by some event, be smoke, hopefully not someone's burnt toast. So I'm going to approach this by doing minimal changes to this, other than adding two wires to the piezoelectric speaker that's on here, or noisemaker that's on here, and bring it out and then build a circuit to condition the output without loading the speaker down or without loading the piezoelectric buzzer down, and have that trigger a latch off circuit to power off the printer. So it looks like from this one that we really only have, I was looking inside here, looks like it's just two spots that we're getting power from to the speaker or to the buzzer, and that would be these two spots. So it's just looking underneath at the buzzer, there's only two contacts by the looks of it. Well, maybe three. So I'm going to power this guy up and put a scope on it and see what the signal off the speaker or the buzzer looks like. And from that, I'll figure out what sort of conditioning circuit we need, or whether I need to add a comparator block in there with a reference. So now I've got all three wires on there. I put three on because there's three terminals. I'm not sure if it's a push-pull type driver on the piezo buzzer. So I brought them all out, and I'll look at all three lines, since I can't really tell from beeping it out with the continuity tester whether or not which terminal is actually connected to an internal ground. Anyway, so we'll run the test and take a look at what the signal looks like. Set it up for normal triggering and do this again. Very good. Alright, so we got something now. And right, so 2 and 4, channel 2 and 4 are, let me get my color coding here, so that's the blue and it's my white and my brown wire are square wave drivers, and my purple wire is giving a sort of sinusoidal output. So I don't really care about those, and this is all reference to the ground of the battery. So it's looking like either one of those square wave channels will work fine. Yeah, so we'll just take a look at this here. Okay, so we're looking at roughly the battery voltage, so 10 volts, which is actually not bad for working with. So we'll just run that one more time. Yeah, so this should be pretty easy to basically take one of those signals, or both of them, and run them into a full wave rectifier and then have that referenced to an internal circle. So that'll give us something around 10 volts average, which is, or the whatever the battery voltage of the 9 volts is, as a trigger signal for shutting down the printer. Alright, so I'll move on to actually creating the conditioning circuit for this. Okay, so now we've got a conditioning circuit on there. So this is basically a low pass filter after a full bridge rectifier. So the full bridge rectifier is taking the two 10 volt square wave 50% duty cycle signals, which are out of phase, and sending it through a bridge rectifier through the AC side of it, and rectifying that into hopefully approximately 9 volt output, which then goes through a low pass filter, and then it's Zener clamped to around 5.1 volts or so. So this will make it compatible with any of the 5 volt logic that's being created for the latch off circuit for the printer, AC power removal. So let's give this a quick test here and see what we get.
trigger. Right, so we'll take it off normal mode here and try that again. So channel 1 is looking at the clamped rectified output. So we'll give this another try again. Alright, so this actually looks really good. It's got some volt spikes in there, which is going to need some additional filtering. But other than that, that's something we can work with. The other thing too is the scope is referenced to the ground of the smoke detector. Now if we remove the reference off of this and make the reference relative to the rectified circuit, which is going to be this side. So this side will be the ground reference. Because the smoke detector is floating, we can do this. And then we'll just give it another shot here. Oops, didn't quite latch that. Let's try it again. There we go. So now we don't have that those spikes anymore. We do have the negative spike, which again we can clean up with a bigger filter. But I'm pretty happy with this. I think we can work with this quite nicely. So so we're a little bit over 5 volts on that, but I mean that's the Zener clamp voltage. If we chose a lower one, like a 3.3 volt Zener clamp, then that would get us close. Since this is going to be going in to trigger a PNP, NPNP latch, it shouldn't be a problem having a slightly higher voltage, but we'll see.